This is example 5 in section 4.9. So for this relation, we want to determine the equation of the tangent line. Now, an equation of a tangent line would be y minus y1 equals the slope x minus x1, where x1 and y1 are a coordinate on the relation, and the slope is basically their derivative at that coordinate. So we know the x and y coordinate is going to be 1 and 2, that's provided, but we have to determine this slope. Again, our slope is our derivative. So we're going to perform implicit differentiation because we have x and y variables to determine that derivative, dy dx. So the derivative of the first term would be 6x dx dx, but we know that dx dx cancels. We're going to do the product rule. I'm going to keep the constant outside and do the product rule on x, y. So you take the first function and you differentiate the second. So that will give you dy dx plus the second times the derivative of the first, which is just 1 dx dx, but that cancels. Again, we have the product rule again. So we go the first times the derivative of the second, which is 3y squared, dy dx, plus y cubed times the derivative of x is 1. And the derivative of 7 is 0. So we got 6x. I'm going to distribute my 2 through. So I'm going to have minus 2x dy dx, subtract 2y. I've got a 3xy squared dy dx. I've got a y cubed, and I've got a 0. Again, we want to group our dy dx's, so I'm going to leave them on the left side, and I'm going to move every other term. And then I'm going to factor out. So I'm going to get negative 6x plus 2y minus y cubed. When I factor out my dy dx, I'll get negative 2x plus 3xy squared equals this trinomial. And then I will divide to get dy dx isolated. So do it to both sides. So my final answer for dy dx will be a combination of these x and y terms. Now, this is the derivative, the general derivative for any tangent line, but I want the derivative at 1 and 2. So I'm going to substitute in those values to find the derivative at this specific point. So I get negative 6 with 1. I plug in 2 for the y. I plug in 2 again. I got a 1 for the x, 1 for the x, and 2 for the y. So when you work this out, you'll get negative 6 plus 4, subtract 8. So that's negative 10. You'll get negative 2 plus 2 squared is 4, 4 threes are 12, so negative 2 plus 12 is positive 10. So you're going to get negative 1. So this negative 1 value is your slope of your tangent at that coordinate. So let's find our equation of our tangent line. So y minus y1, as we said previously. We know the y coordinate was 2. We now know the slope is what we found, negative 1, and the x coordinate was 1 as well. You can leave it in point slope form, or you can multiply out your brackets, and you can solve for y by bringing the 2 over, and you can have it in slope intercept form. Both are correct.